Welcome to Mind Map MCQ. In part 2 of our series on cosmos, we learn about supernova, black holes and much more. We also learn about the life cycle of massive stars and the incredible events marking their end. Perfect for your preparation for competitive exams. So prepare, practice and prevail. 1. What causes a supernova? The options are A. Planetary collision, B. Stars core collapse, C. Black hole formation, or D. Galactic collision. The correct option is B. Stars core collapse. A supernova occurs when a massive star exhausts its nuclear fuel and undergoes a rapid collapse. The core rebounds violently, triggering a powerful explosion that ejects stellar material into space. This explosive event releases an immense amount of energy, outshining entire galaxies for brief periods. Supernovae can also result from the collapse of a white dwarf in a binary system or when a massive star exceeds its Chandrasekhar limit. 2. What is the primary characteristic of a red dwarf star? The options are low temperature, B. short lifespan, C. high mass, or D. large size. The correct option is A. low temperature. Red dwarf stars are small, cool and dim with surface temperatures ranging from 2500 to 4000 Kelvin. They have masses less than half that of the Sun and emit low luminosity due to their small size. Red dwarfs burn their fuel slowly, giving them incredibly long lifespans, potentially trillions of years. Known for frequent flare activity, they emit bursts of radiation. These characteristics make red dwarfs the most common type of star in the universe, influencing the potential habitability of any orbiting planets. 3. What is a star cluster? A. A single star system with multiple planets. B. A region of space with no stars. C. A group of stars bound by gravity. D. A star surrounded by gas and dust. The correct option is C. A group of stars bound by gravity. A star cluster is a group of stars bound together by gravity formed from the same molecular cloud. There are two main types, open clusters and globular clusters. Open clusters contain young hot stars and are found in the galactic disk, while globular clusters are older, denser and reside in the galactic halo. 4. What is a pulsar? The options are A. A type of binary star, B. A white dwarf with strong magnetic fields, C. A black hole with a surrounding accretion disk, D. A neutron star emitting regular pulses of radiation. The correct option is D. A neutron star emitting regular pulses of radiation. A pulsar is a highly magnetized rotating neutron star that emits beams of electromagnetic radiation from its magnetic poles. These beams sweep across the space as the star spins, creating periodic pulses detectable from Earth. Pulsars are remnants of supernova explosions, incredibly dense with intense gravitational and magnetic fields. They serve as precise cosmic clocks due to their regular rotational periods, aiding in studies of extreme states of matter, gravitational waves, and tests of general relativity. 5. Which element is the heaviest that can be formed through fusion in the core of a star before it goes supernova? The options are A. Iron, B. Helium, C. Carbon, and D. Uranium. The correct option is A. Iron. The heaviest element that can be formed through fusion in the core of a star before it goes supernova is iron. Fusion processes in massive stars create heavier elements up to iron, which has 26 protons. Iron fusion is not energetically favorable as it does not release energy but instead requires it. When a massive star's core accumulates iron, it can no longer sustain fusion reactions, leading to a core collapse and triggering a supernova explosion. 6. What is the defining feature of a neutron star? The options are A. High temperature, B. Large size, C. High luminosity, D. Extreme high density. The correct option is D. Extreme high density. The defining feature of a neutron star is its extreme compactness with densities exceeding that of an atomic nucleus. Neutron stars have masses about 1.4 times that of the Sun compressed into a sphere with a radius of only about 10 kilometers. This results in densities around 10 to the power 17 to 10 to the power 18 kilograms per cubic meter, comparable to the density of atomic nuclei, making neutron stars one of the densest forms of matter in the universe. 7. What is the spectral type of the hottest stars? The options are A. M type, B. G type, C. O type, and D. K type. The correct option is C. O type. The hottest stars are classified as spectral types O. These stars have surface temperatures exceeding 30,000 Kelvin, emitting most of their energy in the ultraviolet range. They appear blue or blue-white and are extremely luminous. O-type stars are massive and have short lifespans due to their rapid consumption of nuclear fuel. Their intense radiation and the stellar winds significantly impact their surroundings, influencing the formation and evolution of nearby celestial objects. The next question is 8. What term describes the remnant neutron star left behind by a supernova that emits regular pulses of radiation? The options are A. Quasar, B. Pulsar, C. Blazar, or D. Magnetar. The correct option is B. Pulsar. A pulsar is a highly magnetized rotating neutron star that emits beams of electromagnetic radiation from its magnetic poles. These beams sweep across space as the neutron star rotates, and if aligned with Earth, they are observed as regular pulses of radiation, hence the name pulsar. Pulsars are remnants of the supernova explosions and provide insights into the properties of neutron stars, including their magnetic fields, rotation rates, and the extreme conditions within them. Question 9. How is a black hole formed? A. By a supernova explosion. B. By a collision of galaxies. C. By a comet passing close to a star, or D. By the collapse of a massive star. The correct option is D. By the collapse of a massive star. A black hole forms when a massive star exhausts its nuclear fuel and undergoes a supernova explosion, causing its core to collapse under its own gravity. If the core's remaining mass exceeds around 2 to 3 solar masses, gravity overwhelms all other forces, compressing the core into a singularity. This creates an intense gravitational field with an event horizon beyond which nothing can escape. 10. What is the boundary around a black hole beyond which nothing can escape called? The options are A. Event horizon, B. Event boundary, C. Photon sphere, or D. Gravitational singularity. The correct option is A. Event horizon. The event horizon is the boundary surrounding a black hole beyond which nothing can escape, not even light. It marks the point where the gravitational pull becomes so strong that escape velocity exceeds the speed of light. Inside the event horizon, all paths lead inexorably towards the singularity, the black hole's infinitely dense core. The event horizon is crucial in defining a black hole as it separates the observable universe from the regions of space and time concealed within the black hole. 11. Which of the following star is known as a pulsar? The options are A. Red, B. White, C. Massive, and D. Neutron. The correct option is D. Neutron. A neutron star becomes a pulsar due to its rapid rotation and strong magnetic field. When a massive star explodes in a supernova, its core collapses into a neutron star which retains the angular momentum, causing it to spin rapidly. The magnetic field channels particle emissions along the magnetic poles. As the star rotates, these beams sweep across the space like lighthouse beams. If Earth lies in the path of these beams, we detect regular pulses of radiation, hence the term pulsar. 12. Which of the following is a fossil star? The options are A. Red giant, B. White dwarf, C. Protostar, or D. Dog star. The correct option is B. White dwarf. A white dwarf is called a fossil star because it is the leftover core of a medium-sized star that has burned through its nuclear fuel and lost its outer layer. Without fusion, it gradually cools over billions of years. White dwarfs offer key insights into stellar evolution, preserving information about the past conditions of their original stars and the galaxy around them. 13. What is the term for the distance from the black hole at which the escape velocity equals the speed of light? Options are A. Schwarzschild radius, B. Event horizon, C. Photon sphere, or D. Singularity. The correct option is A. Schwarzschild radius. The term for the distance from the black hole at which the escape velocity equals the speed of light is the Schwarzschild radius. This radius marks the boundary of the event horizon, the point beyond which nothing, not even light, can escape the black hole's gravitational pull. It is a critical parameter in defining the size of a black hole and is directly related to the black hole's mass. The concept is central to understanding black hole physics and their observable properties. 14. What is the process called when a black hole pulls material from a companion star? The options are A. Fusion, B. Fission, C. Accretion, or D. Spaghettification. The correct option is C. Accretion. The process when a black hole pulls material from a companion star is called accretion. As the black hole orbits its companion star in a binary system, its gravitational pull strips gas from the star, forming an accretion disk around the black hole. Friction within the disk heats the material to high temperatures, emitting intense radiation before it falls beyond the event horizon. 15. What type of radiation is commonly emitted by matter falling into a black hole? The options are A. Microwaves, B. Visible light, C. Radio waves, and D. X-rays. The correct option is D. X-rays. Matter falling into a black hole commonly emits X-ray radiation. As material from an accretion disk spirals inward towards the black hole, friction and gravitational forces heat it to millions of degrees Celsius. This extreme heat ionizes atoms, causing them to emit X-rays as they lose energy. 16. What is the singularity of a black hole? Options are A. The edge of the black hole, B. The point where density becomes infinite, C. The outer region of the black hole, and D. The visible part of the black hole. The correct option is B. The point where density becomes infinite. The singularity of a black hole is a point within its center where gravitational forces become infinitely strong. It is considered to be a region of zero volume and infinite density where the laws of physics as we know them break down. It is surrounded by the event horizon beyond which nothing can escape. The existence and the nature of the singularity pose fundamental questions about the nature of space-time and the universe's fundamental laws as at extreme scales. 17. What is the escape velocity needed to leave a black hole's gravitational pull? The options are A. Equal to the speed of light, B. Slower than the speed of light, C. No escape velocity is needed, D. Faster than the speed of light. The correct option is D. Faster than the speed of light. The escape velocity required to leave a black hole's gravitational pull depends on the distance from the black hole. At the event horizon where the escape velocity equals the speed of light, any object or light cannot escape. Closer to the black hole, the escape velocity increases further. This velocity exceeds the speed of light, making escape physically impossible and defining the boundary of the black hole's influence where even light cannot break free. 18. What is the disk of gas and dust spiraling into a black hole called? The options are A. Event horizon, B. Photon sphere, C. Accretion disk, or D. Schwarzschild radius. The correct option C. Accretion disk. The disk of gas and dust spiraling into a black hole is called the accretion disk. This disk forms as material from a companion star or surrounding space is drawn towards the black hole by its intense gravitational pull. Within the accretion disk, friction and gravitational forces cause the material to spiral inward, heating up to extremely high temperatures and emitting intense radiation, particularly in X-rays. Accretion disks are crucial in understanding the feeding process of black holes and their energetic behaviors in the cosmos. 19. What energy is released by black holes? The options are A. Stellar radiation, B. Hawking radiation, C. Ionizing radiation, or D. None of the above. The correct option is B. Hawking radiation. Hawking radiation is a theoretical prediction by physicist Stephen Hawking that suggests black holes can emit radiation and gradually lose mass over time. According to quantum mechanics, near the event horizon, particles and antiparticle pairs are constantly being created and annihilated. Occasionally, one particle falls into black hole while the other escapes as Hawking radiation. This process leads to the slow evaporation of black holes, with smaller black holes radiating more intensely. What is spaghettification? The options are A. The stretching of objects by a black hole's tidal forces, B. The collision of two black holes, C. The spinning of matter around a black hole, or D. The formation of a black hole. The correct option is A. The stretching of objects by a black hole's tidal forces. Spaghettification is the process by which an object is stretched and elongated as it approaches a black hole due to the extreme differences in gravitational forces across its length. Near the event horizon, the gravitational pull on the object's closer side is much stronger than on its farther side, stretching it into a long, thin shape resembling spaghetti. The intense tidal force can ultimately tear the object apart as it moves closer to the black hole, leading to its disintegration. 21. What is the Schwarzschild radius? The options are A. The radius of the singularity, B. The distance from the black hole to the nearest star, C. The radius of the event horizon, or D. The distance light travels near a black hole. The correct option is C. The radius of the event horizon. The Schwarzschild radius is the distance from the center of the black hole to its event horizon, that point beyond which nothing, not even light, can escape the gravitational pull. It defines the size of the event horizon for a non-rotating black hole and is directly proportional to the black hole's mass. This concept, derived from Carl Schwarzschild's solution to Einstein's equation of general relativity, is crucial for understanding black hole properties and their effect on surrounding space-time. What is gravitational lensing? The options are A. The formation of a black hole, B. The expansion of the universe, C. The collapse of a star, or D. The bending of light by gravity. The correct option is D. The bending of light by gravity. Gravitational lensing occurs when the intense gravitational field of a black hole bends and magnifies the light from objects behind it. This bending of light, predicted by Einstein's general relativity, creates distorted multiple or ring-like images known as Einstein rings. Observing these lensing effects allows astronomers to study the properties of black holes, such as their mass and spin, and to investigate distant cosmic objects that would otherwise be too faint to observe directly. 23. Which of the following black holes is closest to our solar system? The options are A. Gaia BH1, B. Sagittarius A star, C. V404 Cygni, D. Cygnus X1. The correct option is A. Gaia BH1. Gaia BH1 is a dormant stellar mass black hole located approximately 1600 light years away from Earth in the constellation of Ophiuchus. It was discovered by the European Space Agency's Gaia spacecraft. Gaia BH1 is notable for being closest known black hole to our solar system. Unlike many black holes, Gaia BH1 is not actively consuming material from a companion star, making it harder to detect and study. Its discovery provides valuable insights into the population of black holes in our galaxy. 24. Who coined the term black hole? The options are A. Albert Einstein, B. John Wheeler, C. Stephen Hawking, D. John Mitchell. The correct option is B. John Wheeler. The term black hole was coined by physicist John Wheeler in 1967. Wheeler, a prominent figure in general relativity and quantum mechanics, used the term during a lecture to describe the concept of an object with such intense gravitational pull that not even light could escape from it. The term quickly became widely accepted and is now universally used to refer to these enigmatic cosmic entities whose gravitational influence shapes the fabric of space-time in profound ways. 25. Which was the first black hole to be identified? The options are A. Sagittarius A star, B. Cygnus X1, C. V404 Cygni, D. GX339-4. The correct option is B. Cygnus X1. The first black hole to be identified and confirmed through observational evidence is Cygnus X1. Discovered in 1964, Cygnus X1 is a binary system where a massive visible star orbits an unseen companion. Observations showed that the unseen companion had a mass too large to be a neutron star, leading astronomers to conclude it must be a black hole. Cygnus X1 remains a key object in the study of black holes, offering insights into their formation and interactions with nearby stars. 26. Which was the first black hole whose image was captured? The options are A. Sagittarius A star, B. Cygnus X1, C. M87, D. V404 Cygni. The correct option is C. M87. The first image of a black hole taken by the Event Horizon Telescope was of supermassive black hole at the center of the galaxy Messier 87. This historic image was released on April 10, 2019 and showed the shadow of the black hole surrounded by a glowing ring of superheated gas that is accelerated to near the speed of light by the black hole's immense gravitational pull. The black hole itself is located about 55 million light years away from Earth in the Virgo galaxy cluster. 27. Which star phase occurs after a red giant sheds its outer layers? The options are A. Neutron star, B. Brown dwarf, C. Blue giant, or D. White dwarf. The correct option is D. White dwarf. After a red giant sheds its outer layers through processes like stellar winds or planetary nebula formation, it enters the phase of a white dwarf. A white dwarf is a small, extremely dense remnant of a low to medium mass star. It is primarily composed of electron degenerate material with a size comparable to Earth but containing a mass similar to that of the original star. White dwarfs gradually cool over billions of years, eventually fading into a black dwarf as they cease to emit significant radiation. 28. What is a protostar? The options are A star before it begins nuclear fusion, B a star in its main sequence phase, C a star in its red giant phase, D a star before it becomes a white dwarf. The correct option is A star before it begins nuclear fusion. A protostar is a nascent stage in the formation of a star preceding its entry into the main sequence phase. It forms from a collapsing molecular cloud of gas and dust where gravity causes the material to contract and heat up. As the protostar accumulates mass, it undergoes increasing nuclear fusion reactions at its core, generating energy that counteracts further gravitational collapse. Protostars are often surrounded by a rotating disk of material and may emit infrared radiation as they continue to grow before maturing into stable hydrogen fusing stars. 29. Which star type undergoes helium fusion in its core? The options are A main sequence star, B protostar, C red giant, D white dwarf. The correct option is C the red giant. Stars that undergo helium fusion in their cores are typically helium burning stars. These stars have exhausted their primary hydrogen fuel and expanded into red giants. In their cores, temperatures and pressures increase sufficiently to ignite helium fusion into carbon and oxygen through the triple alpha phase process. This phase occurs in stars with initial masses greater than about 0.8 times the Sun's mass. Helium burning stars are a crucial stage in the stellar evolution, preceding the eventual formation of more complex elements and transitions to subsequent phases such as carbon burning. 30. What is a globular cluster? The options are A cluster of galaxies, B a dense cluster of stars bound by gravity, C a type of binary star system, or D a dense nebula surrounding a star. The correct option is B a dense cluster of stars bound by gravity. A globular cluster is a densely packed spherical collection of hundreds of thousands to millions of stars bound together by gravity. These clusters are some of the oldest objects in the universe, containing stars that formed around the same time from the same molecular cloud. Globular clusters orbit galaxies in a halo-like structure and are distinguished by their tightly packed, nearly symmetrical distribution of stars. They provide valuable insights into stellar evolution, galaxy formation, and the history of universe's star formation process.